We've already seen how we can use Venn diagrams to represent visually the information that's contained in a categorical proposition, and then in immediate inferences, use that Venn diagram to determine whether an immediate inference is valid or invalid. Well, now we need to expand that, and so we can tell whether categorical syllogisms, which consist of 3 categorical propositions, are valid arguments or invalid. So the first part of this video, really what I'm going to be doing is just laying out some decision procedures, some rules for how to do the Venn diagramming. So this is something that you can get in your notes. You can likewise find this in the text as opposed to the video. And then at the back part of this video, the latter half of this video, we'll try applying the technique. The first set of rules that we're going to go over are ones that apply to both the Boolean and Aristotelian standpoint. So regardless of which standpoint that you're taking, you start off the Venn diagramming this way. First, we only make marks for the premises. So when filling out, making marks in our Venn diagrams, we only diagram the information for the premises. We don't make any marks for the conclusion. We leave off the information in the conclusion. Number 2, do any of your shading before you do any of your Xing. That is, diagram your universal statements first, then you can turn to diagramming your particular statements. 3, each premise deals with 2 of the 3 circles. So when we have the Venn diagram for categorical syllogisms, we have a circle corresponding to our minor term, our major term, and our middle term. Our convention will always be to have the lower left circle be our minor term, the lower right circle be our major term, and the circle in the middle be the middle term. So depending on the proposition that we're looking at, whether it's the premise or the conclusion, it's only going to be dealing with 2 of the circles at any given time. And so you can just focus on those circles, the 2 circles in play, instead of that 3rd circle when you're doing the diagramming. Because we have 3 overlapping circles in our Venn diagrams, when we are placing an X, we're going to be placing an X in a part that's divided. So for instance, suppose we're told that some S's are not M's. Then that means there exists an S that's outside of the M circle. There's 2 places where we have S's that are outside of the M circle, in those 2 pink spots. So where do we put the X? Well, one case is when there's no shading, neither of these areas are shaded, which means they're both in play. And if that's the case, your X goes on this line that divides those 2 areas. And what that tells us, what that represents to us, is at least one thing that exists that the X represents could either be in this area, or it could be in this area, or it could be in both. The other possibility is that one of our areas is shaded. And if that's the scenario that we run into, then since shading means removing that, we put the x fully and wholly within the remaining part. All right, so 5, you'll never have an x outside line of a circle, so you'll never have an x here. That'll never happen, or should never happen. And you should never have an x on the intersection. And what it means by the intersection is where these circles are meeting. So you wouldn't have an x, for instance, here or here, etc. If we're diagramming from the Boolean standpoint, then after we followed the previous steps, what we do is we just revert back to the type of diagramming that we've already covered with the Boolean standpoint. You just make sure that you're focusing on 2 of the circles at any given time when you're doing the shading. Now in testing for the validity, we check to see whether the conclusion asserts more or no more than what is contained in our diagram. If it doesn't contain more information than what is contained in the diagram, our argument is valid, for then the truth of the premises guaranteed the truth of the conclusion. But if the conclusion asserts more than what is contained in the diagram, then the argument is invalid. That is, the premises did not force it to be true what the conclusion states. If we're checking validity from the Aristotelian standpoint, then after we have gone over the first set of general rules that we've already covered, we start by using the Boolean method, the one that we're familiar with. And if it turns out that on the Boolean method the argument is valid, it's also going to be valid from the Aristotelian standpoint. And you'll just know that it's valid and you can stop. The question then is whether it turns out the argument is invalid from the Boolean standpoint. On that case, then we need to check to see whether both premises are universals and the conclusion is a particular. If that condition does not hold, if one of the premises is particular or the conclusion is a universal, then the argument is invalid. And that's because what we're checking to see afterwards is whether the existential fallacy is committed. But if both of our premises are universals and the conclusion is a particular, then we look at our diagram and we check to see whether there's any circles that have 3 of its areas shaded. That has only one area unshaded. So for instance, maybe for our middle term, this area is shaded, this area is shaded, and this area is shaded. If that's the case, then in this last small part, we put our circle X. So just imagine that what I'm doing here is putting the circle X in there. It's hard to tell that's what it is, but that's what I'm doing. Now that we have the circle X in the diagram, we want to check to see whether the conclusion asserts no more than what's contained in the diagram. So if it does assert more, then we know it's invalid, because then there's no way for the premises to guarantee that what the conclusion says is true. But if it asserts no more, then we say it's conditionally valid. And that's what the circle around the X, in case of the circle X, reminds us. It reminds us that at this point we've only got conditional validity, and we need to check to see whether the thing that X denotes actually exists. So we look at the term corresponding to the circle that has the only one shaded area in it, and we ask ourselves whether that thing exists. If it does actually exist, then the argument is valid. But if not, then the argument is invalid and commits the existential fallacy. All right, now that we've got the rules down for diagramming a categorical syllogism in a Venn diagram, let's do that in a particular case and then determine whether using that diagram, determine whether that argument is valid or invalid. So in this particular case, our major premise says that some P are not M. Our minor premise says some M are S. Therefore, some S are not P. So you can go ahead and pause the video, try diagramming this yourself, and then unpause it and I'll give you the correct answer. First thing to remember is that the only information we're going to be diagramming is the information contained in the premises. We're not going to diagram the information that's contained in the conclusion. We also should remember that we want to do any shading, that is, we want to diagram universal statements before we diagram particular statements. In this case, we don't have any universal statements. We don't have shading to do, so that's not a worry. Premise 1 says that some P are not M. That means we can focus our attention on the M circle and the P circle. So in focusing our attention on the M circle and the P circle, we want to think about where we want to put our X. Well, if we're told that there is a P that is an M, that is not an M, then it needs to be in the P circle, but outside of the M circle. The P and the M overlap at 3 and 4. So those can't be the places where we would put an X. The two places that are P's that are not M's is 6 and 7. Since neither of these are shaded, because we didn't have any universal propositions to start with, we put the X along the dividing line between those two parts. And that tells us that this X might be in 6, might be in 7, or there might be P's that are in both of those areas. Now let's diagram the minor premise, some M are S. Well, if there is an M, well, first, since we're talking about M's and S's, we can focus our attention on the M circle and the S circle. And to say that some M are S is to say that there exists at least one M and it's also an S. Well, the area where we have M's that are S's is where the M's and the S's overlap, area 2 and area 3. Again, because we don't have any shading, we're going to have to put our X along the dividing line between area 2 and 3, which tells us that maybe it's in 2, maybe the thing in question is in 3, or maybe it occupies both. Now, in judging the validity, we look at the conclusion. which says some S are not P. So we're told that there exists an S, and it's outside of the P circle. And what we want to know is whether the premises forces that to be the case. You might think yes, because of this X. Because if it turns out that this X is actually an area 2, then we have an S that exists that's outside of the P circle. The problem, however, is what the X being on the line tells us is maybe it's in 2 or maybe it's in 3. We don't have enough information to decide whether it's actually in 2 or whether it's in 3. And if it turned out to be in 3, then it would be an S that is in the P circle. So based on the information that our premises give us, in premises 1 and premises 2, we're not forced to the conclusion. We're not guaranteed that the conclusion is going to be true. So from the Boolean standpoint, the argument is invalid. So then in judging whether it's valid or invalid from the Aristotelian standpoint, we only need to continue if we find out that the argument is invalid, which is what we found out. And then we need to test to see whether the argument commits the existential fallacy. But in order for it to commit the existential fallacy, both of these premises need to be universal. While the conclusion needs to be particular. Since we didn't fulfill the condition of the premises both being universals, then we know that there's no chance for it to be invalid from the Boolean standpoint, but valid from the Aristotelian standpoint because of existential import. So it's going to be invalid for both the Boolean standpoint and for the Aristotelian standpoint. Let's try another argument. This says some M are not P, some M are not S, therefore no S are P. Go ahead and pause the video, try diagramming it and determine whether it's valid or invalid, first from the Boolean standpoint, then from the Aristotelian standpoint. So we can diagram our major premise first. Some M are not P. So we're told that there is an M that exists and it needs to be outside of the P circle. Well, 3 and 4 are areas where you would have M's that are P's. So we need our X to be in area 2 or area 1. But there was no shading. So we need to put the X on the line between the 1 and the 2. That tells us that the M in question might be in area 1, might be in area 2, could even be in both. Our minor premise says that some M are not S. So we're told that there exists an M, but it's outside of the S circle. 2 and 3 are the areas where we have M's existing that are S's. So we need an X in the M circle that is outside of this. That would be in area 1 or 4. Again, because there's no shading, we can't determine which. So we put the X on the line in between 1 and 4. Our conclusion says that no S are P. So it says that there's nothing that exists in area 3 or 6. That's what it asserts. And that's supposed to follow from the fact that we have an M that exists that's not a P, and we have an M that exists that's not an S. But by looking at the diagram, clearly we're not forced into by those premises to the proposition that there's nothing in 3 or 6. Clearly something could be here since there's no shading there. And let's try another one. This one says all M are P, no M are S, therefore some S are not P. Go ahead and pause the video. Try your hand at it. Determine whether the argument is valid or invalid from the Aristotelian standpoint, from both points. All right, so we have all M are P and no M are S. So if we focus on all M are P, we'll be focusing on the M circle and the P circle. And we're told that everything that's an M is a P. Well, area 1 and 2 would be cases of M's that are not P's. So we need to shade out area 1 and 2. Now let's look at our second premise, no M are S. We're going to be looking at our M circle and our S circle. And to say that no M are S is to say that 2 and 3, there can't be anything there since that's where M and S overlap. So we need to shade out 2 and 3. Of course, we've already shaded out 2, but we do need to make sure that we shade out also 3. Then we're told that some S are not P. So there exists an S and it's outside of the P circle. From the Boolean standpoint, since our universal statements don't have existential import, this argument's invalid. There's no X's anywhere on our diagram, so we're not committed from premise 1 and premise 2 that there does exist an S and that it's not a P. So from the Boolean standpoint, it's invalid. But how about from the Aristotelian standpoint? Well, from the Aristotelian standpoint, we need to check to see whether the premises are both universal premises and the conclusion is particular. Indeed, that condition is filled. And because that condition is filled, it's possible, because of the existential import, that from the Aristotelian standpoint, the argument is valid. So we've got more work to do. What we want to do then is we want to see whether there's any circle that has only one area that's not shaded out, or that has 3 areas, likewise, has 3 areas that is shaded out. Well, if we concentrate on the M circle, we see that area 1, area 2, and area 3 are shaded out, leaving only one area 4 that is unshaded out, that remains. So what we do when that happens is we put a circle X in that remaining area. We call this the critical term. If there's something that exists, if the M exists, for instance, then we are in fact committed something existing in this area. If it's a unicorn or a fairy or whatever, something that's non-existent, then we're not committed to that. So let's say it does exist. Our conclusion says that there exists an S and it is not a P. When we examine this, we see that what we're committed to is not an S and is in fact a P. So even though it has existential import, the conclusion is still not guaranteed. The argument is invalid. Let's look at one last argument. This says some M are not P, all M are S, therefore some S are not P. Go ahead and pause the video and try diagramming it and determining whether it's valid or invalid, both from the Boolean standpoint and the Aristotelian standpoint. All right, in diagramming this, hopefully what you noticed is that premise 2 is a universal proposition, which means that we have to shade. And we always do our shading before we place our X's. So the first step in this argument is to diagram the second premise, all M are S. So if all M are S, then area 1 and 4 can't exist because those are areas that are M's that are outside of S. So we need to shade it out. Now that we've done that, we can turn our attention to premise 1. Some M are not, some M are not P. Well, looking at the remaining M's would be 2 and 3. 3 is an M that is a P, but we're told that there exists an M that is not a P. So there needs to be an M that is firmly within area 2, not on the line dividing them. Because it can't be either 3 or 2, it can only be 2. Now we look at the conclusion. The conclusion says that there is some S that are not P. So there exists an S that is not a P. Well, by looking at this X, we notice that in fact it is an S that's outside of the P circle. That is, it is an S that is not a P. So given that these premises are true, the conclusion must be true. And the argument is valid from the Boolean standpoint. And if an argument is valid from the Boolean standpoint, that means it is also valid from the Aristotelian standpoint.